Hello viewers, in this video we will discuss how to find domain and range of various functions. First, number 1, find the domain of the following functions. Number 1, you are given f of x is equal to square root of x minus 7. See, in this video we will discuss the basic functions. It is f of x is equal to square root of x minus 7. Remember, if you get any function of the form 1 by root over a or root over of a, remember, for this function the value of a cannot be is equal to 0, therefore a must be greater than 0. But for this function the value of a can be is equal to 0, therefore a must be equal to greater equal to 0. We know if a number inside square root it is negative, we get imaginary values, therefore the values of a should be always positive. Now x minus 7 under square root, so you can write fx is defined only when x minus 7, the number inside square root should be always positive or equal to 0. Therefore x is greater equal to 7. In the number line I can represent this like this. This is your x equal to 7. The value of x will be greater than 7 or equal to 7 towards the right side. This is infinity. So you can write x belongs to 7 to infinity. This is your domain of this function. Therefore you can write domain of f of x is equal to 7 to infinity. Number 2, f of x is equal to 1 by square root of 3 minus x. See, this is in the form of 1 by square root of a. We know that it is defined only when the value of a will be positive, because when a is equal to 0 it will be 1 by 0, it is undefined. So you can write f of x is defined when 3 minus x, the quantity inside the square root, is positive but can never be is equal to 0. So from here you can say that if I take x on the right side, you'll get x is less than 3. In number line I can locate this as this point is 3. See, it is not equal, it is not equal, it is less than 3. So it will be open interval hollow less than 3 towards the minus infinity. We can write x belongs to minus infinity to 3. This is your domain of fx. Therefore domain of f of x is equal to minus infinity to 3. This is your third function. See, we are discussing the basic functions. Now number 3, f of x is equal to x square minus 5x plus 6 divided by x square minus 5x plus 2. This is a rational function. It is a rational function. We know for rational function f of x is equal to p of x by q of x, where q of x not equal to 0. We know for a rational function it is the ratio of two polynomial function. So provided the qx in the denominator can never be is equal to 0. Similarly here the function x square minus 3x plus 2 can never be is equal to 0. If it is 0 then it will be undefined. See, now I will further try to factorize them. This is x minus 2 into x minus 3. I have found the factors using middle term factorization, and for this it is x square minus 3x plus 2. I can write x minus 1 into x minus 2. See, these two quadratic functions have a common factor x minus 2, so you can cancel them. When I cancel a factor, we must write that x not is equal to 2. Why this? Because when x equal to 2, it is 0 and it is 0. When you will put x equal to 2, it will be 0 by 0. 0 by 0 is called indeterminate form. Indeterminate form. No one can find its exact value. No one can find its exact value. So it is an indeterminate form. So we can write, when I cancel same factors, we write x not is equal to 2. So after reducing, we are getting x minus 3 by x minus 1. So your f of x is equal to, in the form, x minus 3 by x minus 1. Now when x equal to 1, it is something by 0. For x equal to 1, it is minus 2 by 0. So clearly you can write f of x is defined when x minus 1 not equal to 0. Clearly x not is equal to 1. So the values of x are restricted, that x not is equal to 1 and not is equal to 2. Now put any value of x. Now put at any value of x except 1 and 2, and this will be defined. So you can write x belongs to all real numbers except 1 and 2. See, we have excluded the set of elements 1 and 2. So x can be all real number except 1 and 2. Therefore your domain of f of x is equal to all real number except 1 and 2. X can be all real number except 1 and 2. At 1 and 2, the function becomes undefined. Now it is fourth function. F of x is equal to square root of x square minus 4. Square root of x square minus 4. Now you have to find its domain. What is domain? The set of values of x for which y is defined. Now clearly you can say f of x is defined when x square minus 4, the number inside square root, is always positive or equal to 0. If I put x is equal to 2, it is 4 minus 4 is 0. If I take square root, it is 0. So here it can be equal to 0. So I am getting x plus 2 into x minus 2 greater equal to 0. After factorization, I am getting x plus 2 into x minus 2 is equal to 0. Now these two are x plus 2 and x minus 2. They are different factors. We know that product of two factors is positive when both of them have same sign. Either x plus 2 and x minus 2 both are positive, or x minus 2 and x plus 2 both are negative. So your case 1 will be x plus 2 greater equal to 0, x minus 2 greater equal to 0, and case 2 will be x plus 2 less than equal to 0 and x minus 2 less than equal to 0. Now we have two conditions, either case 1 or case 2. From case 1 I am getting x is greater equal to minus 2, and from and x is greater than equal to 2. So when x is greater than 2, clearly x will be greater than minus 2. So I can say that the common case will be x greater than equal to 2. See, we are getting two cases. First case is x is greater equal to minus 2, and for this x is greater or equal to 2. So whenever x is greater or equal to 2, it will be clearly greater than minus 2. Now case 2, I am getting x is less than or equal to minus 2 and x is less than 2. So now we have two cases. First case, x is less than minus 2. Second case, x is less than 2. So if I find the common space, it will be x is less than minus 2. When x is less than or equal to minus 2, clearly it will be less than or equal to 2. So in the number line, I am getting two cases. First case is this is plus 2, this is minus 2. X is greater or equal to plus 2, and second case x is less than or equal to minus 2. So when x lies in the two intervals, it satisfies the given condition. See, if I put plus 2, it is 2 square minus 4, so it's 0. For minus 2, 2 square minus 4, 0. If I take any value in between minus 2 and plus 2, for example, put 0. If I put 0, it is 0 square minus 4. 0 square minus 4. So it is minus 4. It is, and inside square root, I am getting a negative value, undefined. So when the value of x will be 2 to infinity and minus 2 to minus infinity, the value of x square minus 4 will be positive. But here it is negative. Therefore, your domain of x, domain of f of x, will be minus infinity to minus 2 union 2 to infinity. Why union? Because they are disjoint sets, we have to combine them, so we cannot combine. They are disjoint sets, so I write union, the union of two intervals, open interval minus infinity to minus 2 and 2 to infinity. Okay, this is the domain of this function. See, number 5. Number 5 is f of x is equal to square root of 9 minus x square. See, this is a defined functions. F of x is defined when 9 minus x square is greater or equal to 0. Now, if I take this x square on this side, it is x square minus 9 less than or equal to 0. So I have changed their side. Now if I factorize it, I will get x plus 3 into x minus 3 less than or equal to 0. Now product of two factors is less than 0. It is possible only when they are of opposite sign. They are of opposite signs. So you have two defined cases. Case 1, when x plus 3, see, when x plus 3 is positive or equal to 0 and x minus 3 is negative or equal to 0. And for case 2, when x plus 3 is negative or equal to 0 and x minus 3 is positive equal to 0. So you have two cases, when x plus 3 is positive, x minus 3 is negative. Case 2, when x plus 3 is negative and x minus 3 is positive. So from here I am getting x is greater or equal to minus 3, and from this x is less than or equal to 3. From here I am getting x is less than or equal to minus 3 and x is greater or equal to plus 3. See, it says x is greater or equal to minus 3 and less than or equal to plus 3. See, if I do the number line, it is minus 3 and it is plus 3. According to this, the value of x will be greater than 3 and less than 3. So the value of x will lie between minus 3 and plus 3. And for this, x is less than minus 3 and x is greater than plus 3, which is absurd. A number cannot be less than 3 and greater than 3 at the same time. So you can say x belongs to phi, or x is equal to phi. No such element exists. No such element exists. So it is absurd. It is absurd. You cannot find such x which is less than minus 3 and greater than 3 at the same time. So the domain of f of x will be minus 3 to plus 3. In this case 1 satisfies the given condition. If you take x less than minus 3 and greater than 3, it is absurd. No such x exists which is less than minus 3 and greater than 3 at the same time. But if I say x is greater or equal to minus 3 and less than 3, it is possible. X will be lying in between minus 3 and plus 3. 3 and minus 3 are the boundary positions. If I put 3, it is 9 minus 9, 0. For minus 3, it is 0. And if I take any value in between minus 3 and 3, it will be always satisfied by the given condition. But if I take any value greater than 3, like 4, put 4, what is 9 minus 4 square? It is minus 7, an imaginary number. So you cannot take a value exceeding 3 and minus 3. So your domain of fx is minus 3 to plus 3, interval closed. Now number 6, f of x is equal to 1 by x square minus 9, 1, x square minus 1. This is also a rational function. 1 is a rational function and x square minus 1 is a polynomial function, and x square minus 1 both are polynomial functions. So it's a rational function. So clearly we know that f of x is defined. F of x is defined when x square minus 1 will be not equal to 0, because if it is equal to 0 then function will be undefined. So x square minus 1 not equal to 0. So x plus 1 into x minus 1 not equal to 0. See, x not equal to minus 1 and plus 1. X cannot be equal to minus 1 and plus 1. So if I put minus 1, it is minus 1 whole square. 1 minus 1 0. For plus 1 again it is 0. So x can be all real number except minus 1 and plus 1. For minus 1 and plus 1, the function will be undefined. Therefore your domain of f of x is equal to all real number except minus 1 and plus 1. From the set of real numbers, I have subtracted the elements minus 1 and plus 1. So this is your domain of fx. Number 7, f of x is equal to x minus 3 under square root plus root over of 7 minus x. Now there are two defined functions. So we know anything under square root should be always positive. So you can write f of x is defined. F of x is defined when x minus 3 will be positive or equal to 0 and 7 minus x is positive or equal to 0, because both of these two functions should satisfy the condition of the function that is under square root. If it is under square root, the value must be positive or equal to 0. So I'm getting x is greater or equal to 3, and here if I take x on the right side, it will be x is less than or equal to 7. So it says that this is 3, this is 7, this is number line. According to this, x is greater than 3, and according to this, x is less than 7. So it will be in between 3 and 7. Therefore x belongs to 3 to 7. Domain of fx, domain of f of x will be is equal to interval closed 3 to 7. Now we'll discuss about quadratic inequality. It is called quadratic inequality. See, choose f of x is equal to x minus a into x minus b. This is a quadratic function. This is a quadratic function. It has two roots. We know if I compare f of x is equal to 0, then it will yield x equal to a and x equal to b. If I compare f of x is equal to 0, then I will get the roots a and b. On the number line, they will occupy these positions x equal to a and x equal to b. Suppose a is less than b, so on the number line they will occupy this position. Now, if you are given number 1, f of x is greater or equal to 0, that is, find the set of values of x for which the function x minus a into x minus b is a positive or equal to 0, that is, the product of x minus a into x minus b is a positive or equal to 0. So we know that the product of two factors is positive when both of them are positive or both of them are negative, that is, they are of same sign. So your case 1 will be when x minus a into x minus b is, when x minus a is positive and x minus b is also positive. So from here I am getting x is less than, greater or equal to a and x is greater or equal to b. So clearly a is less than b. So if a number is greater than b, then it will be of course greater than a. Therefore the common case will be x is greater than b. And your case 2 is x minus a into x minus b, they are should be of opposite same sign, so x minus a will be negative and x minus b is also negative. Now according to this, it is x is less than equal to a and x is less than equal to b. Now clearly a and b are different numbers. A is less than a is less than b, so it is given that x is less than a and x is less than b. When the number will be less than a, automatically it will be less than b. So your common space will be x is less than a. So from here I am getting that x is less than a or x is greater than b. Therefore I can write x belongs to a minus infinity to a union b to infinity. Now case 2, second case, when f of x is less than equal to 0, that is x minus a into x minus b is less than equal to 0. Now you can clearly see that the number line, this is your a, this is your b. When x is less than a and less than greater than b, the value of the function f of x are positive. See, I have noticed that when x is less than a and x is greater than b, the values of f of x is positive. So clearly when the value of x will be in between a and b, then the value will be negative. See, now the product of x minus a into x minus b is negative. So case 1 will be x minus a is positive, x minus b is negative, that is x is greater or equal to a and x is less than equal to b. And case 2, x minus a is negative, x minus b is positive. So I'm getting x is less than equal to a and x is greater or equal to b. Now this is x is greater than a and less than b. It is possible x will lie in between a and b, but for this a number x cannot be less than a and less than b at the same time. So it is absurd. It is absurd. So x will be in between a and b. So when the value of x will be in between a and b, it will be negative. So whenever you get a quadratic function, when the value of x will be exceeding b and exceeding a, then the product of the function of factors x minus a and x minus b will be positive, and when the value of x will be in between a and b, then it is negative. So you can clearly write, when the product is positive, then x will be exceeding b and exceeding a, and when the product is negative, then x will be in between a and b. Okay, so this is your quadratic inequality.